Hello everyone, today we are going to study the difference between isotopes, isobars and isotones, and in this video I'll be giving you a trick to remember the difference between all of this. So first of all, let me tell you how an element is represented. Element is represented by a symbol where at the base we write the atomic number and at the top we write the mass number, and X is the symbol of the element. Now let's start with the isotopes. In isotopes you can see the term top in here. So top means there is something related to the mass number. So let's see what does an isotope means. Isotopes are the atoms with same atomic number and different mass number. So what does this mean? That they have different mass number, and you can see that at the top the mass number is written. So like this you can remember that isotopes have different mass number and same atomic number. For example, here you can see the isotopes of hydrogen. The isotopes of hydrogen are hydrogen, deuterium and tritium, and in all of these you can see that the atomic number is same, that is 1, but the mass number is different. For hydrogen it is 1, for deuterium it is 2, and for tritium it is 3. Now why these are different? Because they have different number of neutrons. Now, mass number can be calculated as number of protons plus number of neutrons. But here the atomic number is same. And what is atomic number? It is number of protons. So if the number of protons is same, then it means that only the number of neutrons is different for all of these three isotopes of hydrogen. So you can only learn this by the term top in the word isotope. Now let's move to the isobar. In isobar you can see that there is Ba in the between, and this Ba can be learnt as base, and base means there is something related to the atomic number, because in the atomic symbol you can see at the base the atomic number is written. So let's see what is an isobar. Isobar are the atoms of different elements having the same mass number but different atomic number. It is kind of opposite of what we read in isotopes. So like this we can learn that the atomic number is different for isobars. The example is given for potassium and calcium. So in potassium and calcium both you can see that the mass number is same, that is 40 for both, but atomic number for potassium is 19 and for calcium it is 20. So the trick for learning for isobars is Ba, which represents base. Now let's move to the isotones. Now isotones has a N in between. Now this N can be learnt as same number of neutrons. In the definition, isotones are atoms of different elements having same number of neutrons. Now how the number of neutrons calculated? It is calculated as A minus Z, that is mass number minus atomic number. Now mass number, as I already told you, it is proton plus neutron. And what is atomic number? Atomic number is number of protons. If we subtract these two, the protons will get cancelled and we will be left with number of neutrons. Let's see the example. Example given here is boron and carbon. For boron, the number of neutrons can be calculated as mass number minus atomic number, which is 12 minus 5, and we got the answer as 7. Whereas for carbon the mass number is 13 and the atomic number is 6. So it is 13 minus 6, and again the answer is 7. So these both atoms have the same number of neutrons, and that is why they are called as isotones. And here you can learn it as N in between in isotones. So this was a trick to remember the difference between isotopes, isobar and isotones. So in isotopes, top is the word. In isobar, Ba, which represents base, and in isotones it is N, which says it has same number of neutrons.